All right, now the fun ones. We talked a little bit about translation, and I gave you parasolids in the belt tightener example with the limit angles, the limit mates, and that kind of stuff. So one of the things we want to do is just real quick make sure that you can navigate all of that. So now if I can figure out where I hit it. Nope, I hit it better than that. Oh, that was way back. Nope, still not. All right. Oh, that was not the one with the parasols. Nice. Had it all figured out. Nope. How many of these belt tighteners do I have? I should have found that before. All right, so x_t. Tell me it's not in there. There we go. There's the bracket. So let's just go ahead and do the pulley. Open the file location. All right. So that one will work. So when you're opening these up, we already have a frame part. We don't have a pulley part, so that'll work. When you open that, it's going to ask you which template, which part template you want to bring it in with. I believe these were designed in metric, so it will ask you to run the import diagnostics. Parasolid, okay, so the x_t or the parasolid binary x_b. I've never really seen much difference in them, and I couldn't tell you what the difference in them is. So parasolids, iges, step files, sat files, STLs are all typically going to come in and ask you if you want to run import diagnostics. What it's looking for is whatever program it came out of. Did any garbage come with it, or are there any faulty faces? Gaps are fairly common. Faces that didn't resolve are fairly common. And if there's something that shows up here, and let's see, where did I see that last? I'm going to have to tag one of the parts when I get a faulty face, but it will show up as here's the faces, and then attempt to heal all. Most of the time, it will heal the gaps in your imports. Right? As soon as you have it, it shows it as a part file, but the asterisk says it hasn't been saved. We want to save that. I'm going to leave it as the exact same name, hit save. Now it's a SolidWorks file. I can bring it into the assembly. I can work with it in any of the models. Imported just says that if I want to add geometry, I can add geometry. The other one that I don't do a lot of, and it didn't, so apparently I have it turned off, is to do the feature recognition. And it's been long enough that I'm going to have to look for it. Evaluate. All right, so you may get a box that says, do you want to bring this in and make the try and find the geometry, make it SolidWorks native geometry again. Most of the time the answer is no anyway. Whatever we imported, we just imported. It's the geometry is what it is, and I'm more interested in having consistent faces than I am with modifiable geometry. I can add to this, I can do cuts, I can do whatever I want to it. Going forward, I just don't have access to the revolve or to the fillets or the geometry that created this file. All right, take one more quick look. There we go, FeatureWorks, recognize features. So if I tell it to do automatic, it will try to recognize everything as an extrude, a volume, a revolve, holes, fillets, chamfers, and ribs. Or if I go interactive, just recognize this one piece of geometry as a face and make it a cut extrude. And then that would be a sketch and a feature that would be extracted out of this imported solid and be something that I can modify. All right. The problem is that if this updates and it's translated out and we re-import it, then I have to go through that process again. So I want to be careful with those geometries. All right, so I mentioned in the 2018, well, in playing with and even in Service Pack 3, because Service Pack 5 still hasn't come out for 2017. Okay, within the last couple of days, last time I checked, it hadn't come out yet, but we talked about importing files into an assembly. So I grabbed a handful of the NX, which formerly Unigraphics, files that I've been going through the tutorials with, and so, maybe not the assembly, SolidWorks files, and there are the Unigraphics. So notice Solid Edge assembly part, Pro E assembly part, CATIA, Inventor assembly, Inventor part, and then the SolidWorks files. All right, so when I tell it to bring this in, there are my part files. We'll grab one of those. And it comes in, it reads the model geometry. I believe I built those in metric, so we're going to stay with metric. And there is my NX part file. All right, so it pretty much finds the origin, and it has the geometry, it's fixed, and it just has the external references back to that one file with the solid bodies. I'm not going to edit it. I'm not going to make any crazy changes to this because the original file is now capable of driving the geometry. So if it updates in NX and I overwrite the file, or I tell it to overwrite the file, or if the same file is edited on the system in NX and SolidWorks opens it, we'll see that that change in geometry and update the model. All right. Previously, it would do what we just did. It would come in as an imported. It would see the solid body. You would have the part name. You would have imported. And if you wanted to update this, you had to right-click and say, somewhere there should be a replace. Oh, maybe not with the new mix, but that imported file, you would have to right-click on its top-level part name, replace, go grab the new one, and hope the mates came in or remade as you go. All right, so I didn't grab any inventor files or anything, but basically everything that was in that list is capable of coming over as from its native format to interact inside of SolidWorks. And I think most of the modelers are going to go to this because at its base, all of the kernel, the solid body geometry are the same for all the modelers. So even though you don't have access to the features, you don't have the history tree, you don't have all of the things that created this out of NX, you have the geometry, which is what's important, what we need. Okay, so getting this back out. See, did we do? Nope, that wasn't the one I wanted. So let's see if we go back to, now which one was that? Too many belt tighteners. Okay, so that was my subassembly example, pulley bushings, subassemblies. Okay. Had a few fasteners in there for that one. So this is an older version, and I'm in my commercial version, so it's telling me that I built that in the education, so it's it's gonna warn. And so I have this this model ready to do something with. Okay, so at this point, if I open up a file, all right, so we want to output just this one item, then we can do file save as, and continue, because I'm not overwriting the part or changing the name. If I was making this the same part, if I was copying the part or duplicating the part, then that would be an issue because the assembly would see the new updated part, and then the old one gets kind of lost in the mix. But if I go to my translators, parasolid x underscore t, parasolid binary x underscore b, iges, step, so the two different standards of step. IFC is for the electronics. So if you're going out to, oh, there they are again. There's three of them, and I can't ever remember the names of them. All right, but basically the software that generates the trace for your printed circuit boards and component positions. The ACES or the SAT, that was Autodesk's AutoCAD 2013, or not 2013, AutoCAD 13. That still shows up every once in a while. STLs, and then again the standard, and then the DWGs we can output to those files. So once you pick a translatable file, it's going to take you over into the file formats, and we can look at the iges. Do you want surfaces? One thing with iges, it creates a significantly larger file because you have the ability to put the wireframe. You can turn everything on, and this will travel with a monumental amount of data. If you don't need it, no. So iges has been around forever. And you have those abilities. Notice you also have an output coordinate system. So if the file that you're translating into, all right, so you're going into another system, maybe those coordinates are going to be rotated. Their top is our front, or our front is their right, or not likely, but we could go ahead and set up a coordinate system so that the output coordinate system is in relation to when we import it. We're not going to have to do anything weird to it. So the step files was also in Autodesk. I believe in Autodesk you can put out the solid surface geometry or wireframe. And then the ACES, different, and then the parasolid. Usually with parasolids, I like to go back at least a couple of versions, right? So if you're translating, you don't really know where it's going to end up. You don't want to be at 28 and they're using an older version of Inventor and it can only recognize 25. If I go back to 23 or 24, there's kind of a couple year window of versions there that I can I have at least a shot that they're whatever software they're using is going to be able to open it. All right, so whoever I'm sending this to or whoever's sending it back to me. All right, so again, the electronics, the manufacturing, pictures. So all of the TIFFs, Photoshop, JPEGs, PNGs. And then we get into the e-drawings. And I'm not sure if my e-drawings is up to date, so we'll have to try that one out. But one of the things with e-drawings, okay to measure. So it comes down to, do you have a non-disclosure with your product to whoever you're sending this file to for quote? Are they okay to measure it? If they're not exactly the most reputable of organizations, you may not want to let them measure. You can look at it, you can spin it, you can dissect it, but if you want to copy it, you're going to have to invest a significant amount of time in my IP to duplicate my product. All right, so allow export to STL, direct to 3D print. Save table features, drawing files, motion studies. Probably not doing too much of those, so we'll get into those. PDF and the 3D PDFs. So what do you different properties for in each of the items. So let's if we send this out as a parasolid, parasolid and step will both organize. Oh, sorry, I'm still in the part. So we'll just save that out. And no, discard changes. We didn't change anything. All right, so that was at the part level. If I go save as, I don't know why I'm keeping this at 2014, but I'll give it a shot anyway. All right, so at the assembly level, flatten the assembly hierarchy because it's going to take each of those parts and create a separate. Let's see, it's going to create one parasolid file, but when you re-import it into whatever modeler, it's going to create the 10 individual files as individual parts unless we flatten. Steps, kind of the same thing. All right. And we'll save that one up. And no, we don't want to save. All right, so if I go to open those, that's doing all files anyway, so probably the other thing is the naming. I really need to move this to a different folder because I run the risk of overwriting every one of these. Let's just go up to all right, so kind of the assumption is that you're emailing this, you're putting it on Dropbox, you're making it available to somebody somewhere so that they can include it, or that they can quote it to make it, or however you want to proceed. Okay, so the names come in. Nope. Did I do that right? No, it went through the correct sequence. Oh, these are my subassemblies. There we go. There's the imported. All right, so I wasn't paying attention when I was looking at the down. All right, so once I save this, and it's saving back to the same locations, save all. There are all of my parts. There is my x_t. I have all those individual items to work from. And if I had extracted this or translated it in the same folder, I would have probably overwritten all of my data. All right, so that was my concern with getting this over into a separate folder. All right, so translation files are going to be pretty handy. Depending on the company that you're downloading from, I've had companies send me step files. I've had typically step or parasolid. Sometimes they're converted. When we were doing the water pumps, they would send out, I think they were working in Pro-E, and we would get the outside surface envelope and none of the internals. And that makes sense. They don't want us building pumps, but we need to be able to hang the pump off of the back of the truck and figure out where everything connects to it. All right, so there's little tricks to build enough of that geometry back, give it a mass, and make it part of the system. But anything that you can get that you don't have to draw or create is a bonus. All right.